Hello, my lovely students. How are you? Welcome back to the second term. I hope you enjoyed your vacation and ready to learn some exciting subjects. Let's start with your lovely subject. Let's talk science. First unit in this term is talking about friction force, and it includes two lessons: friction and applications of friction. I bet you wanna say that you took fraction in maths before, right? Actually, in science, you will learn about new topic different than what you took in maths. I guarantee it's a completely different thing. So let's know what's meant by friction. To understand what is friction force, I wanted to bring a ball and push it or kick it a little bit on the ground. Leave it to move freely without any interruption. What will you notice? Will it move forever or will it stop after a while? Of course it will stop after a while. You know why? Actually, there is an invisible force or power between the ball and the ground. This force or this power slows the motion or the movement of the ball down till it stops. This force or this invisible power is known as friction force. This power exists between any two surfaces when they touch each other. From the previous slide, I said that there is a force or power between any two touching surfaces, like the ball and the ground. And this force or this invisible power slows the motion of the objects down till it stops. Do you know that you're using friction force 1,000 times every day? Starting from waking up in the morning. There is a friction force between your body and the bed, your body and the blanket either, because they touch each other. Without this force, your body won't be able to be stable on the bed. You will slip down. Also, if there is no friction force, you won't be able to hold the blanket to move it away from you. Then, you walk to the bathroom. You know that there is a friction force between your shoes, slipper, feet, and the ground. This friction force makes you control on your motion and movement. Without this friction force, you will slip down and you won't be able to walk or run or even stand. Then you open the tap. When you touch the tap, there's a friction force between your hand and the tap. This friction force makes you control on opening and closing. Then you wash your hands with the water. You know that there is a friction force also between your hands and the water. Water here is considered as a surface. And I said that there's a friction force between any two touching surfaces, even it was water or air. Then you use your towel. So you're using friction force here. There's a friction force between your towel and the body. Without this friction force, the towel will slip down. Then you're wearing your clothes. Also, there's a friction force between your clothes and the body. Without this force or this invisible power between these two surfaces, your clothes will slip down. Okay, look at this picture and tell me, where is the friction force? Super! Between the fork and your hand. Also, between fork and the food. Super! What about this? Super, there's a friction force between the fish and the water. And that one? Amazing, there's a friction force between the car and the ground. Also, there's a friction force between your body and the car. You know that there is something else here in this picture? Can you think about it? Super! It's between the car and the air. And that one? Super! There's a friction force between your body and this slide. What about this? Amazing! There's a friction force between the pen and the paper. Without this force, you won't be able to write or draw or even hold the pen. What about this one? It's very easy. Super! Rubbing your hands. There is a friction force between your two hands. Without this force, you won't be able to touch anything or hold anything. Then you return back to your bed to sleep. So you can imagine how many times you use the friction force in the day. Well, friction force makes our lives better. Summary: friction force is a kind of a force or power exists between any two surfaces when they touch each other. Friction force slows down the motion of the objects till it stops. It makes us control on our motion or movement. It makes us hold things. It's very important for us, and without it, we cannot live. Look at this picture and tell me, what will happen to the bicycle when that man stops pedaling? Wow, the motion of the bicycle will slow down till it stops after a while. You know why? Excellent, because there's a friction force between the bicycle and the ground, right? Look at the second picture. What do you think? What will happen to the bicycle when that man keeps rolling the pedal? Yep, it will keep moving as long as that man rolls the pedal, right? Why didn't the bicycle stop? Friction force is assumed exists between the bicycle and the ground. So, why didn't the bicycle stop in the second case? Let's know why. In the first case, that man stopped pedaling, so he doesn't get the bicycle any power to move. So, friction force becomes bigger than the movement force. In this case, when the friction force becomes so large, the bicycle stops after a while. However, in the second case, that man keeps pushing the bicycle using the pedal to overcome the friction force between the bicycle and the ground. So, in the second case, the movement force becomes bigger than the friction force, so the bicycle moves. From the previous slide, we can conclude that when the friction force becomes smaller than the movement force, the object will move, because the friction force that makes the object stop is very small and can't overcome the movement force, so the object can move. However, if the friction force becomes bigger than the movement force, in this case the object will stop, because the friction force here is very large. But when the friction force becomes equal to movement force, the object will move, but with a constant speed. And constant here means normal or medium speed. We have known that there is a power between any two touching surfaces, and this power of force slows the motion down till a stop, and it must be bigger than the movement force to be able to stop the moving objects. Now, let's learn another thing about this mysterious power. Look at this picture. There is a friction force between this box and this table because they touch each other. Now, this box is moving. Can you tell me what's the direction of its movement? Does it move to the right side or to the left side? Incredible! This box is moving to the right side. So I can tell that this right side is the direction of the movement or motion. If you want to stop this moving box, what would you do? Will you stand in front of this box or behind this box? Super! You should stand in front of this box so you can be able to stop it easily. So you should stand in the opposite direction of its movement, not with the same direction. The friction force, like us, it works in the opposite direction of the movement or the motion. So it will work on the other direction or the opposite direction. From all what I said in the previous slides, I can conclude the definition of friction force. So, what's meant by friction force? Friction force is the force that exists between any two touching surfaces or between any two surfaces when they touch each other, and it affects in the opposite direction of the movement, or it works in the opposite direction of the movement. So let's say together the definition or what's meant by friction force. Friction force is the force that exists between two surfaces when they touch each other, and it affects in the opposite direction of the movement. If I asked you, write the scientific term, it is the force that works or affects in the opposite direction of the movement. So the answer will be friction force. So let's say it again. What's meant by friction force? It is a force or power that exists between any two surfaces when they touch each other, and it affects or works in the opposite direction of the movement. We have known what's meant by the friction force. Now we will talk about the types of diffraction. Friction has three types. Friction force could exist between any two solids, like rubbing your hands. Your hands are considered as a solid matter. So if you have two solids, the type of friction force here is solid-solid friction. The second one between any solid matter and the air, and in this case is called air resistance. So air resistance is just a type of friction force between any solid object and the air, like moving the plane through the air or falling leaves through the air. So moving any solid object through the air is known as air resistance. Number 3 is the friction between solid and water, and in this case it's known as water resistance. So what's meant by water resistance? It's a type of friction force between any solid object and the water, like moving a fish through the water or ship through the water. So we have 3 types of friction force. First one is friction between solid and solid, any two solids. Number 2 is air resistance, or moving a solid object through the air. Number 3 is water resistance, or moving a solid object through the water. And I will explain each one in details right now. First one is solid and solid friction. We have some factors affecting the friction force, or the friction force depends on these 3. First one, types of the material surface. Number 2, the surface area. Number 3, the speed of the body. Types of the material surface, it means that if this surface is rough or smooth, how could this affect the friction force? Number 2, the surface area means how big or small this object. Number 3, the speed of the body, it means how fast or slow of this object. So we have 3 factors affecting the friction force, or the friction force depends on these 3 types of the material surface. It means if this surface is rough or smooth. Number 2, the surface area, how big or small the object. Number 3, the speed of the body, it means how fast or slow the object is. Now I will talk about each one in details, and we will see how could each one of these affect the friction force. The first one, types of the material surface. So let's watch this video and concentrate very well, because I'm gonna ask you about it after watching it.
Friction. Why is it difficult to pull a boat on the beach than on the sea? Hey, you will find it difficult to pull the boat on the beach. Pull it on the sea. There it will be quite easy.
Indeed, why not?
Fine, don't listen.
Oh, I'm so tired.
At least now try to pull the boat on the sea. It is quite easy. Right?
Yippee!
Do you know why? This is because of friction. Friction is the force which opposes the motion of an object. It always acts in the direction opposite to the direction of motion. The amount of friction depends upon the texture of an object and the surface on which it is being moved. Rough textures or surfaces offer greater friction as compared to smooth textures or surfaces.
Arg! Do you want to say that my brand new boat has a rough texture?
No! Even though the texture of the boat is almost smooth, the small particles of sand present on beach form a rough surface. Hence, when we pull the boat on beach, the sand particles offer greater friction and oppose the motion of the boat, thus making it difficult to move the boat on the beach. However, the sea being a liquid forms a smooth surface. Hence, when we pull the boat on sea, it offers less friction, thus making it comparatively less difficult to pull the boat on sea.
Okay, have you watched the video? Now the question is, Which surface was the easiest for the boat to move on? Sand or water? Of course water, you know why? If you got the previous video, you will get the answer. Yup, because the sand is a rough surface, and rough surfaces increase the friction force, and water is a smooth surface, and smooth surfaces decreases the friction force. Look at this picture. What do you think? Which type of land is the easiest for the boy to skate on? A or B? Of course A, or ice. You know why? Because A, or the ice, is a smooth surface, and smooth surface decrease the friction force, so the boy can move easily through it. There is nothing can stop it. But B, or grass, is a rough surface, and rough surface increase the power of the friction force, so it's hard for that boy to skate on grass. So we have two types of surfaces. We have smooth surface and we have rough surface. Smooth surface decrease the friction force, but the rough surface increase the friction force. So in the smooth surface, the object can move for a long distance easily because the friction force is very small. But in the rough surface, the objects can move for a short time till it stops because the friction force here will be very large. And if you forgot which one is increase and which one is decrease, just remember this password. IRDS. IRDS. I for increase. Remember guys that the friction force increase where, in which type of surface? Super on the rough surface. So IR here, I for increase and R for rough. Okay, so the friction force increase on rough surfaces, and D here means decrease and S means smooth. So IR increase on rough, DS means decrease on smooth. So if you forgot which one is increase and which one is decrease, just remember this password, IRDS, IRDS. I increase on rough surface, D decrease on S smooth surface. Okay, if I asked you, complete the following. Friction force, what? On the sand. By the way, guys, sand is a rough surface. And what? On the glass, and glass here, as you know, is a smooth surface. So friction force increase or decrease on the sand or on the rough surface. I told you before, if you forgot, just remember your password, IRDS. So R means rough, so the previous letter here is I, increase. So the friction force increases on the sand or increases on the rough surface. And what on the smooth surface? Super, it decreases on the glass or any smooth surface. The second factor is the surface area. And as I said before, the surface area means how big or small the object is. I want you to look at these two pictures and tell me, which pair of shoes can you use it to walk or run easily on the ground? Sneakers or ice skating shoes? Of course you will choose sneakers. You know why? Because sneakers have large surface area on the ground. It's larger than this small blade on the ice skating shoes. And when we increase the surface area, what will happen to the friction force? It will increase too. And this relation between the surface area and the frictional force is a direct relation. What's meant by direct relation? It means once we increase the surface area, the frictional force increase, and when we decrease the surface area, the frictional force will decrease. That's meant by direct relation. So, increasing the surface area increases the frictional force and vice versa. It means when we decrease the surface area, the frictional force decreases. So if I asked you here, give reason, the relation between surface area and frictional force is a direct relation. The answer will be because by increasing the surface area, the frictional force increases. And when we decrease the surface area, the frictional force decreases. The last factor is the speed. And the relation between speed and frictional force is like the relation between surface area and the friction force. It's a direct relation. And we said before what's meant by direct relation. It means by increasing the surface area, the friction force increase, and decreasing the surface area, the friction force will decrease. The same happens with the speed. By increasing the speed, the friction force increases, and by decreasing the speed, the friction force decreases. To understand the relation between speed and friction force, let's take this example. Look at this picture. That dog wants to catch Tom. So, the faster Tom runs, the faster the dog too, trying to stop him. So, by increasing the speed, the friction force also will increase, trying to stop the motion of the object. So, let's prove that there is a direct relation between speed and friction force. Look at this picture. What do you think? What will happen to your feet when you run for a long distance barefooted? Yep, that would be hurt, right? But if you just walk barefooted without running, what will happen to your feet? Would it hurt like running? Of course no. You know why? That happens because the more you increase your speed, the more the friction force increases, trying to stop you. That's why you can feel the effect of the friction force on your feet. From here, we can conclude that there's a direct relation between the friction force and the speed. By increasing the speed, the friction force increases, and by decreasing the speed, the friction force decreases. And that's meant by direct relation. I hope you got this lesson. See you next time.